So when we work out our derivative, I think the first step might be to always try to write the expression and the power of x in the expression as whatever its power happens to be. So we know the cube root of something is to the power of a third. And because it's in the denominator, it's x to the power of minus a third, minus 1. And so now if we work out the derivative and the different notations, so I might put dy dx. So the power comes out the front, so we get minus 1 times minus a third, so I get positive a third, x to the power, take 1 from the power, so it's minus a third minus 1, minus, now don't forget, a constant is the same as x to the power of 0, so the derivative of negative 1 is 0. So from here, we can just tidy up our expression and write that as 1/3 x to the power of minus 4/3. And we could, write it like that. We sometimes try to write it as a positive index. Okay, so we might write our final derivative in that form here. All right, let's do the same thing with b. Just rewrite x times x to the half. Well, that's x to the 1 times x to the half, and if the base is the same, we add the powers. So that's x to the power of 3 on 2, minus 2x minus 1/2 of x squared, and I might write y dashed, just a different notation. Power comes out the front, take 1 from the power, 3 on 2 minus 1 is a half, minus 2x to the 0, minus 2 times a half is 1, x, take 1 from the power. So tidy up. So we might go for 3 on 2 x to the half. We might write it as the square root of x. X to the 0 is just 1 minus x. Okay, so just rewrite a function each time as the power. If we have a division, we will look at rules probably next year. There are different rules that we can apply to working out our derivative. But for the most part, if our denominator has a single entity in it, usually the easiest way to differentiate that is to just split everything up. Yeah, so x goes into 1 and x goes into negative 3x squared. So f of x is equal to x to the power of minus 1 minus 3x, because x cancels with the squared. Now let's differentiate. So I've got f of x, I'm going to put f dashed of x, minus 1 to the minus, take 1 from the power, so it becomes minus 1 minus 1, minus 3. Derivative of 3x is just 3. So we might write that as negative 1 over x squared minus 3 as f dashed of x. So that's my gradient function. That's a rule that helps me find the gradient anywhere. All right. Finally, okay, if we've got a bracket, there will be some rules that we come across, but let's expand the bracket first. So let's, I might leave it as that. Don't forget, it's just not the first term squared minus the second term squared. So I get 1 on root x times 1 on root x, which is 1 on x, because square root of x times the square root of x is the square root of x squared. 1 on root x times negative 1 is minus 1 on root x. Minus 1 times minus 1 on root x. Negative 1 times negative 1 is positive 1. So let's write that where our powers. So 1 on x is the same as x to the minus 1. 1 on root x, well, root x is x to the half. 1 on root x is x to the minus a half. So I've got 2 lots of that, plus 1. Okay, so what I've done so far is just expanded those brackets. Now, g of x, so it's g dashed of x, minus x to the minus 2. Negative a half times negative 2 is positive 1. X, negative a half minus 1 is minus 3 on 2. And then the derivative of 1 is just 0. So the derivative g dashed of x is equal to, what's that going to give me? Minus 1 over x squared. Again, we might write plus 1 over x to the 3 on 2, which you could write as x to the power of 3 on 2 is x cubed to the power of a half. The square root of x cubed is just a little bit tidier. I'll make that clearly a negative sign. Yeah. So look, either form is really quite valid. All right. So it's just a case of practicing manipulating the polynomial expression. Okay. Write it so that you've got a good idea of what the power is, and then just apply the rule. Multiply the term out the front by the power and take 1 from the power. Righto.